Hello everyone. Today I am going to explain you discrete time convolution, and this is my fourth lecture on digital signal processing. In last three lectures I have discussed about discrete time signals, discrete time systems, and why we need DSP, and I have discussed about convolution also. What is convolution? Now today let me just tell you some points. What is convolution sum? Now, if you remember that the response of a linear time invariant system to the unit input, say unit sample input delta n is h of n. That is called impulse response. That means we have a unit sample input applied to a LTI system. Output should be impulse response hn. Now, linear time invariant system, that means if it is time invariant system, then if we delay the delta n by k minute, output, that is impulse response, should delay must be delayed by k unit itself. Now, according to linearity, as you know that linearity means for a linear system it must follow two principles, that is homogeneity and principle of superposition. That means if we homogeneity means if we multiply with a scalar factor alpha, output should be multiplied by alpha itself. So we can multiply that delta n minus k with xk, then output should be multiplied by xk with h of n minus k. Now, according to the superposition, if we sum up from minus infinity to infinity k value, output should be same as sum up of k goes to minus infinity to plus infinity. Now, if you recall that xn is nothing but summation of k goes from minus infinity to plus infinity sk into del of n minus k. That is the xn. So xn, if we apply to LTI system, output should be yn. So what we can say here, yn is nothing but k goes from minus infinity to plus infinity sk h of n minus k, or xn convolution of hn. Now this one we can write as x of n minus k into hk also. Okay, so that we have seen in last lecture. So this is the convolution, and this operation is known as convolution sum or convolution. Now what are the basic steps that is here in this formula of convolution sum? Now here we have xk and hk term first. We must have sk and hk term first. Then what we have to do, we have to do the flip operation or folding operation or time reversal operation to get h of minus k. So from hk we will get x of minus k. Then we have to perform the shifting operation or advancing operation depend on the value of n. So we have to get h of n minus k. Then we have to do multiply operation, xk into h of n minus k. Then we have to do summation operation from minus infinity to plus infinity. That is the value of k. So in convolution sum we have four operations, that is flip or time reversal or folding operation, shifting operation or advancing operation, or say you can say delay and advancing operation, multiplication and summation. Now generally there are three basic methods are there by which the convolution of discrete time signals can be computed. Those are graphical method, tabular method and matrix method. Now the general step that we have to follow. So first we have to consider, say in problem it is given xn and hn value. So we have to consider hk and hk as function of k. K is a dummy variable. Okay. So then we can list the input xk and hk. Then we have to find out h of minus k by flipping or time reversal. Then we have to obtain h of n minus k. Okay. That is reflect hk about the origin to get h of minus k. That is a time folding or time reversal operation. Now you have to shift the reflected sequence by n. That means h of n minus k. Okay. Now n, if it is greater than 0, it moves towards right hand side, and it will move towards left hand side if n less than 0. N minus k, right? K is the variable. If you n is say 1, 2, 3 positive value and greater than 0, then k equal to positive value of n. So it should move right hand side, and if n is negative less than 0, then k will be equal to negative value. That means it should move towards left hand side. Now we have to cross multiply and sum the non-zero overlap terms to produce yn. Now that we will discuss with an example also. Now we have to slide h of n minus k to the right by one position. Repeat the multiplication and summation to get output values. Unless there is no overlap. Okay. Stop it. All the output values are 0 or if required. Okay. So this is the general step. Now let us see the example and you have to find out. Now before going into that, let me just show you one point, that is, say we have we have to do linear convolution, xn and hn is given, so yn we have to find out. Yn is nothing but, now here what we can see, you have to see the limit. Now here this arrow or origin is not marked. That means the first element is itself the origin. Okay, otherwise it should be marked by an arrow sign. So we have the starting element, the starting point of k value, that is equal to 0 here, and for hn also 0. How many samples are there? 4 samples are there. Here also 4 samples are there, right? So the main point is that let the starting point or position of first sample of xk is a, and for starting point or position of first sample of hk is b, then starting point of the first sample of hn should be a plus b. That means in this case both are 0 0, so starting point must be n equal to 0. So it has to start from 0. Okay, now if it is say minus 1 and xn is 0, then that should be from minus 1. Like that way you have to proceed. So first you have to find out the starting point or first sample position of yn. Next, what should be the number of sample at yn, of the sample yn. Now say length of xk sequence or number of samples, that is n1, and length of hk sequence or number of sample is n2. Then the length of yn or yn sequence or number of samples of yn, that should be n1 plus n2 minus 1. Okay. So what you can see here, that there is 4 plus 4, 8 minus 1, so 7. That means it should go from 0 to 6 altogether, second sample. Now here you can see we have 0, 1, 2, 3, 4, 5, 6. We have values. 7, it becomes 0. So yn is 0 for n less than 0. Obviously that will be 0, and n greater than 6. That means it has values from 0 to 6, right? So total 7 data or 7 samples are there if we convolve this xn and hn. Okay, so this is how we can find out the starting point of yn and total number of samples in yn. Okay, say for example here we have this arrow is given as the location of origin for both the cases. So for both x and h, the starting point is minus 1. Okay, then starting point of output yn should be minus 1 plus minus 1, so minus 2. And here the length of xn is 5 samples are there, and h is 4, so the length of yn should be 5 plus 4 minus 1, that is equal to 8. Okay. Now this is the example where we have used only the summation formula to find out, but what is the starting point and total number of sequence, that you have to find out from these two formulas. Okay, now here we can see y is 0, so n equal to 0 if you put here, and 0 here, and here is also 0, then k values from 0 to 0, so x k, that means x0 h of n is 0, k is 0, so 0, so x0 into h0, and limit is from 0 to 0, so only one value. Now n equal to 1, that means k value goes from 0 to 1. Okay, now what we can write, xk into h of 1 minus k, right? N is 1. Now k you have to vary, so k one time it is x0 h1, another time when k equal to 1, x1 into 1, 1, 1 minus 1 0 h0, then you can find out the value. Similarly, when n equal to 2, you have to put here y of 2 and here x of 2 minus k, so x of k h of 2 minus k. Now you have to put k value 0 once. If you put k value 0, x0 into h of 2, x0 into h of 2, then plus x of, then k value goes to 1, x of 1 h of 1 2 minus 1, then when k value is 2, that time x of 2 h of 0, so you'll get the value. Like that way we have to compute. Okay, now for n equal to 7 we will get after multiplication equal to 0. So here what we are doing is, we are just implementing according to the formula. We are not proceeding, we are not following any other steps. Simple application of the summation formula. Okay. So I have told you only 3 steps. So n equal to 3 also you can do 3, 4, 5, 6, no problem. Now let us see convolution sum using the graphical method. The first method let us take as graphical method. Now in graphical method what you have to do is we have to plot the xn and hn first, then convert xn to hk, just making the dummy variable as k, x of k. Then hn we can find out h of minus xk, h of k and h of minus k. Now h of minus k will be what? At 0 it will be 2, at minus 1 it will be minus 1, at minus 2 it will be minus 1, at 1 it should be 1. So this is now your 0, right? N plus 1, now this is your n plus 1 point, n equal to minus 1, that means n plus 1 equal to 0, so n plus 1 point, and n minus 1 and minus 2 goes here, so it is physically flipped look of the origin point. So if you place a mirror here, that will be mirror image. Okay, so so x of k value is 2 1 minus 1, this one. So we have to perform xk is given, so 1 0 1 minus 1, that is 0 1 and 2 sample. Now say what should be the starting value actually. Actually starting value will be what? 0, and here it is minus 1, so that should be minus 1. How many elements should be there? Here we have 4, 3, 7, minus 1, 6. So minus 1 and 6. Now see here, we have taken minus 3, h of minus 3 minus k, that value is 0. Minus 2 minus k, that value is 0. Minus 1, we will have some value. Now let us see y. Now see h of k, if you take h of minus k, what will happen? 2 will be at 0 only, 1 goes to plus 1, minus 1, this goes to minus 1 value, and this minus 1 goes to minus 2 value, right? Now if you want to shift h of minus 3 minus k, what will happen? K equal to minus 3, that means we have to add minus 3 to each k value, right? That means 0 position will be multiplied by summation by minus 3, 0 plus minus 3, that will be equal to what? Minus 3. So this is your 0, minus 1, minus 2, minus 3. You can see here, this is your minus 3, right? And this one was there at 1, so it is at 1 plus minus 3 at minus 2. Similarly, these two goes from minus 1, minus 2 to minus 4, minus 5, right? So it is added by this h of minus k term, added by plus k added by plus minus 3. Okay, so as minus 3 minus k. That means now here if you want to multiply xk and h of minus 3 minus k, we can see there is no overlapping. That means this is started here and this is started 0. So there is no overlapping data, so that we can multiply. Here we have 0, so it will be 0. Here we have 0. If you multiply, it will be 0 only. Now if we do h of minus 2 minus k, then minus 2 is 0 is here, so minus 2, that means k equal to minus 2, but we have to add. So 0 minus minus 2, so it will come to at minus 2 position. Here you can see minus 2, and this one at minus 1, or else we can see minus 3 is here. Now we are adding plus 1, so it is shifted by 1 unit. This is shifted by 1 unit. Okay, now if you see here, there is no overlapping. Here we have last first value is here, so this value is 0, so 0, and this value of h of minus 2 minus k into 0, so it will be 0 only. Okay. Now see what happened when we take minus 1 minus k. That means this 2 is goes to a minus 1 and this 1 goes to 0, right? H of minus k. Okay, so here this h of minus 2 minus k, that is shifted by 1 unit. That is why it's minus 1. So this shifted here. Now we can see if we look this term and xk, what we can see that this term is common factor overlapping with each other. Xk and hk, xk and h of minus 1 minus k overlapping at this point. So if we multiply these two, that is 1 into 1, so result is 1. Now if we take h of 0 minus k, that is the flipped operation. That means 2 is here, 1 goes here, minus 1 goes here, and minus 1 goes here. Or else we can say plus 1 with that, so it will shift right hand side by 1. Now you can see we have these two value overlapped with these two value. So this is 2 into 1 and 0 into 1, so it will be 2. Similarly, h of 1, this is 0 minus k. If it now h of 1 minus k, that means h of 0 minus k, we have to shift it by another unit, 1 unit. Okay. If you shift that, we can see we have these three data are overlapping with each other, right? So if we cross multiply that, and we will get the result. Again 2 minus k, if we shift again this data by 1 unit, now see this data is shifted by 1 unit right hand side. Now we can see we have 1, 2, 3 data overlapping, and this data is now multiplied with 0. Again 2, 3 minus k shift by another unit. Then we can see here that these three data, these two data is now overlapping with this, and this one is 0. So these three data is overlapping, and when we take 4 minus k, again shifted by 1 unit. Now what we can see, only this one data is overlapping with that, other two data are 0. Now if we take h of 5 minus k, this will go out here, this point, that is 3, x equal to 3, k equal to 3. So k equal to 3, we don't have any value for xk. So again it will be 0 forever. If you go 5 minus k, 6 minus k, like that. That means how many data are there? Minus 1, 0, 1, 2, 3, 4. Now see here 1, 2, 3, 4, 5, 6, 7 data. Total n1 is 3, n2 is 2, 4, 4. So that is 7 plus minus 1, 6. There must be 6 data. So this is h of minus 1 minus k, 1 data for 0. Then 1, 2, 3, 4. Total 6 data are there. 6 data are there. So that is the graphical method. Now this is really time consuming to perform this kind of operation. We have only 4 and 3 data, so it is easy. If data is on more, then it will be take tedious job to find out. Now let us take an example of the tabular method. Say we have xn and hn is given. Now what is the starting point? No arrow is not provided, so by default first value is the starting point. So starting point of xn is 0, length is 3. Starting point of hn is 0, length is 3. So starting point of the yn should be equal to what? Nothing but 0 plus 0, that 0, and length n1 plus n2 minus 1, so that is 5. Now what we have to do is, we have to, this is your x, we have to write for k. This is the location of the k indices, 0 to 5 here and minus 1 minus 2. Okay, we can go minus 3 minus 4 also, that is not required for this case. Now xk value is given 3 1 2, that is 0 1 and 2, so we have to take care of the indices value also. And hn value is 3 2 1. Now if we find out h of minus k, 3 will remain at 0, 2 must move to minus 1, 1 must move to minus 2. So this is your h of minus k. Now we have to start from yn equal to 0. So this is your starting point, n equal to 0 up to 0 to, basically 5 data should be there, that means 0 to 4, right? So 0 1 2 3 4 5, it will be going out, so it will be 0. Okay, now we got h of minus k here, right? Now we have to multiply xk with h of minus xk into h of 0 minus k. Multiply, the result will be 9, that is equal, that is the value of y equal to 0. Now if h of 1 minus k, right, that means k equal to 1. So h of minus k is this one. If you add plus 1, so this value goes to minus 2 plus 1, it goes to minus 1, minus 1 plus 1 goes to 0, 0 plus 1 goes to 3. So it is moving right hand side by 1 unit. Now if we have to multiply sk with this h of 1 minus k, so we have to multiply indices by indices. So for 0 indices, 3 into 2 6, 3 into 1 6, 3, total summation 9. Now h of 2 minus k, so this 1 minus k have to shift again by another unit, then multiply, that is 3 2 5 6 11, that is y2. y3 you have to shift right hand side once again. Okay, now k equal to 3, so you can put h of minus k here. 3 means 3 minus 2 plus 3, that value should be 1. See here, this is 1. Minus 1 plus 3, value should be 2. 0 plus 3, value should be 3. So those values are shifted by 3 unit, h of minus k. So this is h of 3 minus k. Okay, so now we have to multiply. So 1 into 4 5. h of 4 minus k, we have to right shift by 1 again, and 2 into 1, and these two are 0 0, so 2. Now if you make 5 minus k, you can see this value goes out of the, there is no overlap after this point. When h equal to n equal to 5, then there is no overlap. Okay, so it is goes out of range, so it will be 0 always. So before, after n equal to 4, it goes out of, there will be no overlapping, so it will be 0. And if you take minus 1 of n minus k, so that means if you shift by left hand side by 1, then it will be, there will be no overlapping, so again it will be 0. So the actual range is from 0 to 4. This is the 5 that we have calculated from this particular formula. Okay, so these are the yn value. Now let us take another example. Here we have xn and hn value, and we have this arrow located in these two positions. So xn starting point minus 1, y hn starting point minus 1. Then what is the starting point of yn? Minus 1 plus y minus 1, that is minus 2. Length, here the length of xn is 5 and 4. Sorry, 4 and 4. So 8 minus 1, that is 7. So length should be 7. Now what should be the starting point of yn? Minus 2. What should be the end point? We have 7. That means minus 2 plus 7 minus 1. That will be 4. So it will be, last value should be n equal to 4. So starting point minus 2, then minus 1, 0, 1, 2, 3, 4. So altogether 7 values are there. How we can find out that? Starting point plus length minus 1. Starting point is minus 2, length is 7, plus 7 minus 1, then what is the value? 4. That is the end point of the sequence. Okay. So here now say k value, that is 0, 1, 2, 3, 4, 5, and here minus 1 to minus 4. So we have to write the values properly. So 2 must come as minus 2 per location, then 1, then minus 2, 3. For hn, 1 must goes in the 0th position, k equal to 0 position, then 3 at minus 1, 2, 3 at 1 and 2 position. That is okay. Now we have to find out h of minus of k. Now h of k is this one. So we have to find minus of k. 0 value will be at 0 only. So that is 1. Okay. And 1 goes to minus 2, minus 1 goes to minus 1 position, 2, k equal to 2 goes to minus 2 position, k equal to minus 1 goes to k equal to 1 position. That gives us h of minus k. So it is nothing but mirror image looking at keeping a mirror at location 0. Okay, 3 here, 2 here, 3 here. Now we have to find out starting point is y of n is minus 2. Now here you have to write h of minus 2 minus k. Right? That means k equal to what? Nothing but minus 2. So with this h of minus k, we have to add minus 2 again. If you do that, minus 2 value goes to minus 4, minus 1 goes to minus 3, 0 goes to minus 2, 1 goes to minus 1. Now if you look xk into h of minus 2 minus k, there is a overlap. There is a overlap. Okay. That means the result is nothing but 3 and we can multiply. So 3 into 2, 6. There is only one value overlap, so only one value. There is no summation comes into picture. Now when h of minus 1 minus k, then what happened? That means what? We have to shift right hand side by 1. Or we can take like that, h of minus k, here k will equal to minus 1. Minus 1 minus k equal to 0, so k equal to minus 1. That means h of minus k, here you have to add k equal to minus 1. That means minus 2 plus minus 1 minus 3, minus 1 here is minus 2, 0 goes to minus 1 location, 1 goes to 0 location. Now if we look into h of minus 1 minus k value with h of x of k, that we have here these two values are basically overlapping. So now we can multiply 2 into 1, then we can sum plus 3 into 1. So result is 5. Similarly, h of 0 minus k, that means similarly h of minus k, then the overlap, and you can find out the overlap, multiply in this wise and take the summation. So like that way you have to go on. Okay, unless we reach the end point. End point is what? Starting point minus 2 plus length minus 1. 1 minus 1 because of the 0th position. Okay, so you have to go up to n equal to 4. Now if you see, if you take n equal to 5 minus k, that means this 3 goes this side to the right side. So at location 3, k equal to 3. That means this data is not overlapping with hk anymore. So this value will be 0 always. So that is the our expected range of vision, okay, for the convolution operation. So this is the tabular method. Now let us take the example of uh, matrix method. This is very easy, but how to calculate is very easy, but we have to remember this point. Okay, stop now. I am taking the same example. Okay, so starting point, end point, that we know. Okay, now what happened? And always remember that you have to always locate the arrow mark. Here y of 0 is minus 1. So here you have to mark the arrow. That is very important. If you if you forget that, then what will happen? Y0 becomes this one, 6. And that will be the wrong result. Okay. So now what happened? Here h value is written here. It is 3, 1, 2, 3. X at column wise. In column we have written the h value, and at row we have written the x value, 2, 1, minus 2, 3. Then what we are doing? We are doing just multiplication, just like matrix. So here 3 into 2, that means 6. 2 into 1, 2. 2 into 2, 4. 3 into 2, 6. Similarly, from this row into column, 3 into 1, 3. Then 1, 2, 3. Then minus 2 into 3, minus 6. Then minus 2, minus 4, minus 6. Then 3 into 3, 9. 3 into 1, 3 into 2, 3 into 3. Okay. So just simple. We have written the h value column wise, x value row wise, and just we are doing matrix multiplication. Okay. Thus the multiplication of row and column values. Okay, and putting in same value in same location. Now what we have to do is we have to take diagonal values. So this is 6 and it has only one value, so this is 6 value. Then diagonally if you look, we have these two values are there, 3 and 2. So you have to add these two values, that is the next result 5. Then for next we can see these three values are diagonally connected. So that will be 5 minus 6 minus 1. Then you can see these four values are diagonally connected. So you will get the value as 15. Then these three value, two value, last one value. So you get this value. And according to this, you have to put the arrow mark here. Okay. Don't forget to put the arrow mark, because from here we cannot find out. We get only the values or data, but we don't know what is the arrow here. For tabular, we can find out where is the origin location y0. From here we cannot find out directly. So we have to starting point minus 2 minus 1, so then it is 0 and it will be 4. 1, 2, 3, 4. So like that way you have to proceed to calculate that. Now let us take an example of convolution of uh, to infinite length sequence. Okay. Suppose you have to find out yn of un, convolution of un. Now according to the convolution sum formula, that is k goes from minus infinity to infinity, un change to uk, and then this un also change to u minus k, and shifted version, that is u of n minus k. Right. Now what we have to do is, let us take plot the uk. Uk means a step response, unit step response. So values are 1 greater than equal to n equal to 0, n greater than equal to 0. For 0 it is 1, 1, 1, 2, 1, 3, 1, 4, 1, it will go up to plus infinity. Okay. Now if we find out u of minus k, that is the folding version, then what we will have? At 0 it will be 1, at minus 1 it will be 1, minus 2, minus 3, it goes up to minus infinity. That is u of minus k. Now say if we put k n equal to greater than 0, right? That means k n equal to 2. Then k equal to 2. That means it has to start from the value of n equal to 2 or value of n. So when we take n u of n minus k, where n is some value for n greater than 0, okay, not less than, greater than 0, that means it goes at greater than 0 position in here, n minus 1, then it will go on 3, 2, 1, 0, and it will go to up to minus infinity. This is for n greater than 0, u of n minus k. Now similarly, u of n minus k when n less than 0, what will happen? Less than 0 means negative value. So k equal to negative value, so it will start from some negative value n. So this is minus 1, 0, and this will go up to minus infinity. So here we have two conditions. One is u of n minus k when n greater than 0, another one is less than 0. Now when n less than 0, what will happen if you sum k equal to minus infinity to infinity uk into uk n minus k, that is equal to yn, then that means this term multiply with this u of k, okay, this uk, what we can see, this n can be at minus 1 also, okay, that is n less than 0, it cannot be 0 but at minus 1. Now if it is at minus 1 also, that means this part is multiplied by this part, which is 0 for uk. For uk, n greater than equal to 0, it has unity value, n less than 0, it is 0. So 0 into some value here, 1 for each indices, so it will be, gives us 0. And for n greater than 0, what happened? Here we have the value 1, but here we have 0. So if we multiply that, that will be 0. So total y1 value will be what? Nothing but yn equal to 0 when n less than 0. Now when n greater than 0, what happen? N greater than 0. For this case, into u of k. This one into this u of k. Then what we will get? 1 into 1, 1 into 1, 1 into 1, 1 into 1. It will go on up to n. So what we can say? We can write un equal to minus infinity to infinity uk u of n minus k. Now here the range is what? This is before 0, it is 0, so 0 into 1, so it will be 0, no problem. So here it will range, we can write as 0 to n, right? 0 position 1 into 1, 1 position 1 into 1, 2 into 1, 3 into 1, it will go up to 0 to n, summation of 1, 1 into 1, uk is 1, u of n minus k is also 1, because this is unit step response, magnitude is 1. So from 0 to n, summation of k equal to 0 to n 1. Now what is the result of that? If you sum 1 n time, that will be n. But we have a k equal to 0 also, there is one another 1. So n plus 1 into un. So convolution of un convolve with un, that gives you result as n plus 1 into un. That means convolution of a causal signal, un is nothing but a causal signal which has values of what? Positive values of n, or it has if past values only. Present is 0 and past values. It doesn't have future value, that is a negative values of k, okay, or n, whatever. So causal signal convolution with causal signal gives you a causal signal. So this is why we are writing a multiply by un, because this is 0 to n. So this is for n greater than 0. Okay. Now say another example of infinite series convolution, half to the power n un convolve with un. Now according to convolution sum, yn equal to k equal to minus infinity to plus infinity, half of n change to k uk into u of n minus k. This is changed to uk, then u minus k, then u of n minus k. Now half to the power k uk, if you plot, what you can see, when k equal to 0, it will be 1, then k equal to 1 half, k equal to 2 1 by 4, 3 1 by 8, then it will go on up to infinity. As it is multiplied by uk, now uk equal to 1 n greater than equal to 0 and 0 n less than 0. So less than 0, whatever the value, that will be 0 only, because it's multiplied by uk, and this value multiplied by 1, it will remain the same. Now this is your uk, that is k greater than equal to 0, value is 1, k less than 0, value is 0 for uk. So u of minus k is nothing but at 0 position it will be 1, minus 1 1, minus 2 1, minus 3 1, it is just flipped over. That is the time reversal operation or folding operation. Now for n less than 0, what happens? If we perform u of n minus k when n less than 0, that means k equal to negative number, so it can goes to left hand side, so it starts from n. It can start from n, some n minus 10, minus 12, minus 15, or it can start from minus 1 also, and it will go up to minus infinity, right? Now if we multiply this uk with u of n minus k when n greater less than 0, that is the y of n, that will be equal to what? Nothing but 0, because here we have positive some values 1 1 1 1, and here we have all values as 0. So multiplication and summation gives us result equal to 0. Right? Now if we find out n minus u of n minus k n greater than 0, that means k equal to n positive value, so it will start from some positive value n minus 1, then 2 1 0, it will go on. Now if we multiply this u of n minus k for n greater than 0 with this half to the power k uk, right, for n greater than equal to 0, what will happen? This part is 0 into something, so this part is 0, there is no problem. Now for this k equal to 0 to n, here it is n, so k equal to 0 to n, half to the power k uk u of n minus k, u of n minus k is nothing but 1, right, and this uk is also 1. Then what we can write, if k equal to 0, then that will be 1 plus k equal to 1 means half, k equal to 2 means half to the power square, half to the power cube, so last value half to the power n. Now this is a geometric series, so summation you have to find out, that is 1 minus half to the power n plus 1 divided by 1 minus half. Okay, so you can rearrange that term. So here it will be 2 minus 1 by 2. So that 2 we can take upside at numerator. So 2 into 1 minus, now half n plus 1. So you can divide that, or we can write that half to the power n into half. So you can now 2 you can bring into the bracket. So that will be 2 into, now here half will cancel out. So 2 minus half to the power n u of n. So that is the convolution result of this infinite series convolution. Okay. So, so try to practice more problem. Okay, try to practice more problem of these. These are the finite with finite length convolution sum. Okay, using graphical method, using the formula only, graphical method, then tabular method and matrix method. And this is the example of infinite series convolution. Okay, so this is it for today. Thank you so much.